Hello, this is the part 4 on research methodology or just basic talk on how to do research, especially for young people and young researchers. So the previous videos you can get from here. So in this presentation, I would like to mention how to select a problem. So I'm Ahad from the University of Dhaka and currently I'm working at. So these are the basic steps that for any research we try to identify the problem, which is the most important part, and reviewing information, proposal, experiment, data collections. Finally, we do analysis, deep analysis, and then conclude with some generalized. So, in the previous third lecture, we mentioned about literature review, which is very important to know what is going on. So it means that reading the works of others before starting your own research work, just like we learn from the past to build the future. This slide, we'd like to mention about how to find a problem or what are the strategies to do. There are many ways, but I gave some ideas. So, for example, I think that we need more interactions. Young researchers should attend different domestic or international conferences or meetings or workshops and or courses. There are many courses online, many lectures are online, and during COVID, many conferences are going on online. So you can attend those to get different ideas. Don't miss the chances to attend lectures or talks all over the country. I'm not talking about China or America or Russia. Consider, your region like Bangladesh, for example, a small country, and parts of India you can explore in your region, even if it is not directly related, because at the upper level, many areas are related. Like if you want to do biological image processing or cancer research, but it may need biology, sensors, programming, say signal processing, and so on. We need to discuss informally with different colleagues and interested members. Be part of IEEE, ACM, Optical Society of America, and so on, different student branches, clubs, online forums related to your field, so that you can know what is going on around and how people are thinking, and you convert your gossip adda into academic brainstorming session. Don't just spoil your time. I mean, have more discussions on topics do some brainstorming and do it regularly so that you can try to change the. So you need more in-depth study. If there is a problem and it's big, try to split it into smaller and manageable research and so on. And budget is important in many cases, and in many developing countries there is no budget compared to the rich countries. So what to do? This is a difficult task. Even I struggle, but ask your parents, for example, for the young researchers, or rich relatives or alumni to fund you. Hopefully they will give. Engage your money and best efforts on. So know your capabilities and limitations. This is important. If you do not know your limitations and capabilities, strength and weakness, then you cannot move further. This is important. So, and you need a supervisor. I found that some young boys and girls, they make group, they try to do something, but they don't have any supervisor. So they struggle and produce something which is not good. So at least during the planning phase, engage more time with the supervisor, and then you do an update and update, and this way you can make it better. Try to develop something. Uniqueness is important. No exact repetitions of other works. Try to change or modify or upgrade or at least do some kind of experiments. At least, do some change, not, copying another method. Okay. Evaluating a problem is important. Think, is it feasible? Is it worthy? Is it significant? Is it researchable? Is it too large? If, then, as I mentioned, split into smaller portions. Availability of the data, setup, resources. Like if you want to work on big data, a big image or video data, for example, or sensor data, but you do not have that much setup or resources or computers. So you cannot work. So you should think on different areas where you can fit well. This is one example. Am I capable of solving it? Yes, you can. Okay. Consult with experts and non-experts, because this is important. Experts will guide you. Non-experts related to the field will give you some perspective on society, social issues, and others, so that you can tune your method or model or thinking. Think about, will the results advance knowledge? Will the research have some value? Will the results be of interest to others? If all are yes, this is excellent. But I understand that in many cases it's not possible, especially within short time. But at least try to focus on these points so that it can be better. Okay? And in many cases, researchers, young researchers, they try to do something or anything to learn. But if you focus on this, then the learning. So for any solution, what we do? We need hypothesis or gaze. A gaze is an educated gaze. I mean, a hypothesis is an educated gaze, knowledgeable, based on theory, which I mentioned in previous slides or previous presentations. It is an attempt to explain the nature of the relationship between the variables you identified in the problem. Look at my lecture on 1 and 2 so that you can get on those issues. And you try to attempt to suggest a possible answer to the problem. Okay, so this is an should be an educated and knowledge based and theory based. So it's not new because we do a lot in our daily life, like when you gossip, and then when something is lost or unusual things happen, we think many ways. We find, oh, maybe this, and find logics and logics and logics. We think a lot about many unnecessary things. But what about research? Do we give time? Do you think in the morning, at noon, during lunch, okay, before sleeping? If you think a lot about your problem and possible solutions, then you will. So, to solve the problem, you attempt to link what is known and what is not known and suggest a possible reason or propose a solution. In this way, you are hypothetical. Finally, we do experiments. Do experiments as much as possible. Need diverse experiments in different situations and conditions. I mentioned in one of the previous lectures where I mentioned that if you have real data, that is the best. If you do not have real data, then go for artificial data or simulated data. And I gave an example on gait recognition. You can have a look in the previous lecture. If it fails, ensure to make experiments on different cases. For example, many undergraduate students or so on, they do small works like line follower robot. Yes, it can move on a smooth path, but learn some control engineering methods and electronics and try. What about on grass, on sandy path, on concrete roads, or slippery path, or in the darker area, or occluded path, or zigzag path, or muddy path, or upward directions, or downward directions? I mean, do you think that your line follower robot that you built, a few weeks ago, and try to concentrate on something different to improve? I mean, this is also important. I find, thousands, not thousands, about several hundred students who did line for robot, and they do year after year the similar things, and not much challenge and not much change, because these are not based on theory, based on knowledge. They learn something and they are trying to do something. Instead of looking into direct petty applications, look into how you can control and do. This is very important, that whatever we do, we try to analyze, discuss, or generalize. We need to analyze in depth, considering where it works well and why. You need to know where it fails and why. You have to answer. What are the boundaries of this method or this approach or application it can perform? Show experiments and theoretically, and so experimental and theoretical proofs. Not only experiment, give some theoretical reasonings for that. Okay, if your method or approach is based on theory, this is the most important thing. Okay, where it may work upon some improvements that you could not try, mention those in the future work or discussion part. Be concrete on your finding. Regarding that, you need mathematical and statistical analysis and tools for investigation. Don't just mention by simple graphs or something that this is done, this is the result. Now, but we have much more tools to explore. Need comparative results analysis with other state of the art works. State of the art means latest works. The problem is, if it is not possible, in many cases it's not possible because your time or resources or work or method is not that up to that level. So what to do? At least give some kind of comparative theoretical point of view discussions in your discussion part or result analysis part with state of the art methods. Not every method will be the best one or better one than the existing one, but is it comparable? If not, what are the reasons? Maybe your method is not comparable in one data set or another data set, but it has something which is good or maybe reasonable. So try to find this kind of things. Okay, don't just make your results on a small data set and don't just submit like that. Data visualization tools, I mean, there are lots of data visualization tools. Try find and use them. Running time or complexity is important. Cost, is it realistic, implementable? These are important. I have lots of publications in the past. I don't have this kind of things, but still I'm learning, so I'm sharing based on my knowledge. Thanks a lot. Let's work the hardest. And in the next slides, I'll cover paper writing, reviewing, selection of journals, conferences, scrap or versus standard. You can find the videos here, and the lectures are based on these materials, especially from Khalid's lectures. And you can subscribe the link and share with others. Thank you so much.